Greetings, everyone. Through here, welcome to the DemoHub. When we think about databases, structure comes to mind. And if we think about structure within the database, a table is something we cannot miss. In a database, data is typically stored in obviously tables, and then there are views and other things, but table is really at the core of it, especially for structured data. Now, in a platform like Snowflake, there are different types of tables you can create. As a matter of fact, there are up to 6, if not more, different table types you can create in Snowflake for different use cases. Now, in today's demo, we're going to go through the different table types. We're going to explore their pros, their cons, what are the use cases for those table types. And hopefully, at the end of this, you would be equipped with the understanding of the variety of table types available in Snowflake and how you can deploy them for your use cases. Some of these might be a refresher, but I'm hoping that there might be some surprises in there for you. Now, the very, very first table type in Snowflake, and this is something that most people working within the platform will use, even if you're not conscious about it. If you come into Snowflake and create a replace table, give this a name, by default, this is a permanent table. There is no need to specify a predicate here to say this is a permanent table. By default, Snowflake treats this as a permanent table. Go ahead and create this table. A new table has been created for us, and we can insert some records into this table and verify the results. This is something that you typically would do in your integration process, inserting some records into that table, and we can query this table. We've inserted 5 records, and those 5 records do show. What we've done is essentially created a permanent table. Now, permanent tables obviously come with a number of benefits. For one, it's a permanent table. It persists. Unless you proactively drop this table, it will persist within my session, across session, and anyone else on the platform who has access, the correct roles and privileges to view this table can see that table unless you drop it. This is the default table type. It gives you the highest protection of your data and recovery. If you're taking advantage of things like time travel, you can take advantage of it. So if I create a table and do want to take advantage of time travel, by default, most people will be using a permanent table. If you don't specify any predicate, you are using a permanent table. The next table we're going to look at here is a temporary table. Like the name says, creating a temporary table in Snowflake is pretty straightforward. In this case, the syntax is essentially the same. Create, replace. We specify temporary and table to give this a table name like before. And the syntax for this creates us a table, and we can insert records into the table as before. And the query or the select statement to the table looks pretty much the same. So for a user who simply sees a table name, it might not be obvious to them that this is a temporary table or not. And we're going to talk about some caveats. Where and why do people consider using a temporary table? For one, as the name sounds, temporary table is temporary. It's a shorter duration table. It doesn't persist for a long time. As a matter of fact, it only persists for the session in which that table is created. This could come in really handy if you're doing ETL, you're loading data, you want to do some transformations in a table to temporarily hold that data. And once the job has run, you don't want that data to persist. You want to use a temporary table in that case. There are a couple of drawbacks. Obviously, as your session ends, you lose that table, you lose the data, you cannot get it back. And the benefits of things like time travel in Snowflake, where you can literally go back in time, which is an amazing skill to have. You lose that with a temporary table. There are ways to get it from a day or so, but you gotta really be careful with that. You have to think about it as a transitory thing to do for ETL, ELT jobs. This is where a temporary table comes in handy, and there is no fail safe. So if something happens, catastrophic error, you can go back and try to recover this temporary table. So use that judiciously. The next table we're going to look at is the transient table. So similar to the temporary table, a transient table provides a certain level of resilience to your data a little bit less than your permanent table, but a little bit more robust than your temporary table. So transient tables, the syntax for that would be create or replace. You specify the decorator here called transient table, and you can give this the table name. Once you create your table, you can go in and insert records into your transient table as before. Query this very similar to any other table, and those records would show. Now, there are certain obviously benefits and drawback to a transient table we should consider. Number one is, again, something which is transient means it's not as permanent, it's not as resilient as your permanent table. Unlike in temporary tables, there is time travel in the transient table up to a day. So you can have a day of time travel, but nothing more than that. And unlike the temporary tables, this can persist across sessions. So if you have a job and that job ends and the next job has to run, this will go across sessions. Multiple users can access a transient table, but multiple users cannot access a temporary table, depending on what your workflow is and the use case for it. If you're going to have multiple people querying the table across sessions, you want to use a transient table in this case. Obviously, with time travel, it gives you a certain level of durability, but without failsafe, you got to be careful about using a transient table. So again, ETL jobs comes in handy for this, and jobs where the data durability isn't as important. If you're going to want to keep that data to be more secure, you're going to want to put that on a permanent table and take advantage of time travel and obviously the fail safe. Now, we've gone through 3 tables here. We've looked at the permanent table, we've looked at temporary table, we've looked at transient table. But what's interesting is when we query this table, it might not be obvious to the user what kind of table this is. Is this a permanent, a transient, or a temporary table? Now, depending on the privileges you have, you can always query the Snowflake information schema to tell you the table types. In this case, we're going to run a simple command here. Go into information schema, the tables, and look for the database and the schema where table is underscore table. And that's because every table we've created, we had the suffix as underscore tibia. Here, we do see the tables we've created. I've created quite a bit of tables. There is the transient table we've created. It does tell you the retention time and tells you if it's transient. In this case, it's yes. There are different fields you can bring back. The permanent table, obviously, is not transient. The temporary table is local temporary for the table type. We've also created some external tables. We'll touch on that later, some other different table types. So this is something that you can always query this to get an idea of the table type you're working with, if it's a permanent or a temporary table. The next table type we're going to take a look at is the external table. As the name sounds, an external table is a table from within Snowflake that references data outside of Snowflake, externally to Snowflake. This could be data in your cloud object store like S3, AWS S3, Azure Blob, or Google GCS. With just the way this works, certain performance considerations to think about when using an external table, because that data is not managed in Snowflake like a permanent table. You lose some of the statistics, the micro partitions, and the optimization Snowflake provides with internally managed data. But for use cases where data is coming in externally, an external table could be a handy way to take advantage of that. We've done a complete demo on creating and using external tables, creating storage integrations, pointing to your S3 bucket, and setting that up for the whole 9 yards. But if you've gone through that demo, links to that will be in the description somewhere in this video. The process is pretty straightforward. Create or replace external table. The decorator here is external, telling us this is an external table. And we need a location to read from. So this is the stage we're reading from. This is where the files reside. This is an external stage pointing to S3 location. Go ahead, execute this. This should create an external table for us, and we can query the external table. And this data doesn't reside in Snowflake. The customer first name, last name all reside in the external stage location in S3, and we are accessing that from inside of Snowflake. Really powerful. The next table type we're going to take a look at is a dynamic table. This is a very flexible capability that allows and streamlines a lot of data engineering process. To appreciate dynamic tables, we're going to jump right in and take a look at what the syntax for a dynamic table looks like. So similar to the previous table, to create a dynamic table, we do a create or replace. The decorator here would be dynamic table. In this case, specify that. But there are a couple of things that are unique. One is we're going to specify a lag. So a dynamic table is a declarative way of updating the dynamic table based on a select statement or queries from other tables. So here the lag is we want to have this dynamic table. It's a table that refreshes often, being refreshed every 1 minute, and you can change this to whatever the time frame relevant for this is. The warehouse we want to use for this refresh is specified, and as always we go in and we specify the select statement. So you can put in any arbitrary select statement, selecting from multiple tables, joining, grouping by, doing aggregations, and Snowflake takes care of querying those base tables for new changes and keeping your dynamic table up to date. The best way of describing this is think about it as almost being a view, but you're materializing the result of that view. So a view, every time you query the view will refresh and give you the latest record. Dynamic tables does something similar, but it just materializes that for you. Now, the question would be, how is this different from a materialized view? I'll leave links in the description below to explain the differences, but the big difference is a materialized view has a limitation of supporting one base table. So if you have a query in the materialized view, the base table on that could be from one. But a dynamic table has no such limitation. So you can query from your permanent table, do your joins, aggregations, counts, all of those. And the dynamic table takes care in a very declarative way of keeping this up to date for you. In this case, go ahead and create a dynamic table. And this is simply giving us the count of first name and how many records we have in that table. So if I execute this, the table has been created. We select from there. There should be no records because the dynamic table hasn't executed yet. Timeline is 1 minute, but we can force that to run quicker than 1 minute. I'm going to go ahead and refresh the table. So what this is doing, it reads from the base tables. It does the logic in a very declarative way, and it's updating my dynamic table. Going back and querying the dynamic table, we do see one records of each. And to test that this is actually being refreshed, go back and insert a couple of records into the base tables demo permanent. This is where we're querying from. Insert a couple of records in there. Now my base table has 7 new records. If I wait 1 minute and I requery the dynamic table, we should see our aggregates should have been refreshed, right? So this is the table that could be consumed by your reporting layer. And the dynamic table really serves as that streaming or that data engineering pipeline for you, similar to what the streams and the task we do, but all of those is combined into one and being kept up to date for you. Go back and requery. We can see the dynamic table has been updated. As always, as new records come in here, if we insert some more 7 records, do a quick refresh immediately. As soon as the refresh runs, our dynamic table will always be up to date based on the lag we've set for this table. So a very powerful data engineering option to have that saves you the effort of creating streams and reading from that to load the task. This could be a very flexible way. Before we jump into number 5 and number 6 options, I want to pivot for 1 second to showcase certain options for viewing dynamic tables because these are really powerful. If we go back over to our databases, demo, schema, tables, you see the tables that show up here, but the dynamic tables we've created is actually a first-class object and it does show up within the UI. Here are the dynamic tables we've created. I can click on one and this gives us a graph, and this graph is really powerful. So here is a base table we're sourcing from. If we had multiple base tables, you're going to see this dark. So they directed a cyclic graph showing. from your base tables and your dynamic tables being refreshed. You can have other tables depending on this. You can really have an interesting, very sophisticated data pipeline leveraging dynamic table that's always up to sync and being refreshed based on your lag. So very powerful. We're going to do some more demos on this, but this is something that if you're not taking advantage of, you definitely want to jump in and take a look at dynamic tables, especially for streaming ingest, streaming use cases, IoT. This could be a really powerful option to have. Now, going back into the table types, we've seen 4 so far. The next table type we will see is the hybrid tables. So hybrid tables is, and the link here is going to be in the description as well if you want to go in and read the hybrid tables. I'm not going to demo that. But if you have use cases that requires OLTP, so transactional workloads with very high throughput, very high query per second, so QPS, or transactions per second and TPS, you want to look at the hybrid table. It's in preview, but the link here if you want to go ahead and try this. So Unistore is the technology, hybrid tables is the table type you get to create. Links to this will be in the description below, but you should be very aware of the hybrid tables. The last, certainly not the least, would be Iceberg tables. For data lake, you want open table format. Apache Iceberg is a very capable technology, and being able to leverage Iceberg in Snowflake with Iceberg tables is a powerful option. So this link will be in the description below. Really recommend you take advantage of that. The syntax for this, I'm not going to demonstrate this, but just to call out the syntax, will look something like this. So you're going to create an external volume and point to the location of your data. This will be the volume of the data where you have your Apache Iceberg data or your packet data. Once you've created that, you can simply come in and do create or replace. Your decorator here will be Iceberg table. Go in with your table name, and instead of a stage, you're going to point to your external volume, which is what you refer to for Apache Iceberg, and you can query that table in Snowflake. Very, very performant. I think the question is always, if there is an external table, why Iceberg? Iceberg is a very powerful table format. I'm not going to go into the details of a table format. We'll cover that in different discussions. But the performance you get from Apache Iceberg should be way superior than what you get from an external table, just given the metadata and how that all works. There are different options for Apache Iceberg, like a Snowflake managed Iceberg table or an externally managed Iceberg table. So read on the documentations. We're going to go into more demonstrations on this as it comes online, but a very, very capable table format to be aware of. Just to recap, we've seen powerful table types in Snowflake, and actually a bonus in there, even though we counted it as one, the permanent table. We've also seen the temporary table, which is considered a bonus because depending on your use case, you might or might not be using temporary tables that much. We've seen a transient table, external tables, looking at data from external storages, dynamic tables for pipelines and ingest and IoT and lots of use cases. We've looked at hybrid tables for transactional OLTP type workloads with really high concurrency, high query per seconds, high transactions per seconds, very powerful. And also the Iceberg table for more flexible open data lake format with great performance on Snowflake. Hopefully these are helpful. If any of this is new to you, I'll recommend check out the documentation. Are you using any of these tables? What are your experiences with them? I'll recommend you go down into the comment section below and share those. This has been Fru with DemoHub, and thank you for sticking with us to the end. As always, I'll see you in the next demo.